Fantastic job, you guys. So now we're on this next part. We're in the explain to. We can find this on page 83. We are now going to solve compound inequalities using our word or. So now or is our big word here. Let's take a look. The graph of a compound inequality involving or is the union or combined region of the simple inequality graphs. So taking a look at our or table here, we have all real numbers less than 2 or greater than 6. So as my equation, I'm going to have x is strictly less than 2 or x is strictly greater than 6. Okay? So just like our rules for our and graphs, we take a look at our inequality symbols. Okay? These are less than and greater than symbols, therefore I have open circles on my graphs. They're open, open, open. We do not include 2 and 6. But let's take a look. X is strictly less than 2, so my arrow is pointing to the left from 2. Or x is strictly greater than 6, so my arrow points to the right of 6. Notice that these two arrows will never, ever, ever come together. They will not touch each other. Okay? That's how I know my graph is going to be an or graph. Okay? I have two separate pieces. There is no overlap. Okay? Just like there's Bell. Just like our table in our first video, the only thing that changes in our second row are these symbols, the less than or equal to or greater than equal to signs, okay? And this is where we close our circles at 2 and 6 because now that value is included and we can draw our arrows as follows. So let's take a look at this second example that our book did for us. Okay. We're given a compound inequality and we're wanted to graph the solutions. So we have -4 plus x is greater than 1 or -4 plus x is less than -3. I can treat these two inequalities separately. Okay? They don't overlap. They're just in this number sentence here using my word or. So let's solve for x first. If I wanted to get x all by itself, I'd have to undo a -4. And how do I undo a -4? We add 4 to both sides. So that's exactly what they did here. We add 4 to both sides. So then my 4's cancel out. I'm just left with my x. I bring it down, bring down my sign, and a 1 plus 4 gives me a 5. One equation's done. Take a look at the next one. I want to get x all by itself. So I want to undo a -4. I want to undo adding a -4. But how do I undo a -4? I'm going to add 4 to both sides. This is what they do here. They add 4 to both sides. My 4's cancel out. One's negative, one's positive. I bring down my x, which is left over. My sign still stays the same. And a -3 plus 4 more gives me a +1. Now that I have solved for x twice, I get to graph each of these two pieces. So if x is greater than 5, I'm going to find 5 on my graph. Strictly greater, it's an open circle, and then I fill my arrow into the right. X is strictly greater than 1. I'm going to find, whoops, not greater than. That was my fault. X is strictly less than 1. So I'm going to find my 1, open circle, and shade everything to the left of it. Now when I graph my union, I'm going to graph both of these arrows on the same number line. So I'm graphing my x is less than 1, or x is greater than that positive 5. So let's take a look at a different example. Let's take a look at example 2 here. Letter B on page 84. We have 2x is less than or equal to 6, or 3x is greater than 12. They're separated for us, so let's get x all by itself in both of these inequalities. If I want to get x all by itself, well, here it's being multiplied, and how do I undo multiplication? Division. I'm going to divide by 2 on both sides. Divide by 2, divide by 2. My 2's will cancel. I'm left with an x. 6 divided by 2 gives me a 3. One equation or inequality is done. Now let's do our second inequality. Let's get x all by itself. How do I undo multiplication? Division. I'm going to divide each of these sides by 3. Divide by 3. Divide by 3. My 3's go ahead and cancel. I'm left with x. Bring down your sign. And 12 divided by 3 gives us a 4. Three last steps. Okay. First, let's graph our inequality we found in the first. X is less than or equal to 3. I'm going to find my 3. Open circle or closed circle? That is a closed circle. I have that or equals to. So I have that symbol that has an equal sign underneath it, or equals to. So x is less, which means my graph is going to the left. My second piece, x is strictly greater than 4. So I'm going to find my 4. Open circle, close circle. Open circle. Okay, it is strictly greater than 4. So I'm going to send an arrow to all my values bigger than that 4. The very last step is to graph the union. We're going to combine these two graphs. I'm going to bring down my closed circle on 3 and my arrow going left, my open circle on 4, and my arrow going right. Okay. Now you can take the time. I want you to try your turn problems, numbers 6 and 7, on page 85. When you are done, come check your answers in with me.